Hello and welcome to the Kielder Observatory podcast. I'm Ian Brannan. I'm alongside Dan Pye, who's Director of Astronomy here at Kielder Observatory. And, it is broad daylight. It's the middle of summer. It's still July. And I dare say above us, the clouds are starting to clear, which is good for your session later on.
Yeah, I'm quite hopeful that we're going to get some clear skies. The midge will come out, though, if the wind drops down. That's the worst thing about this time of year, I think, is the onslaught of midge that descend on us. But interestingly, actually, on a future podcast, I did hear this week that we can get a specialist to talk to us about midge.
I thought you were going to say we can get a midge on.
No. It's a really big midge. No, there is a specialist in flies.
Oh, right, okay.
Who we can speak to, I think, on the next podcast.
Great. Well, that'll answer some questions.
Yeah.
I'm not sure. Will it answer questions about space or just about midge?
Just about midge. But also, I think there's something interesting about dark skies and the way that flies react to dark skies. Because, in particular for moths, dark skies are pretty important.
Yeah.
So, and midge as well, maybe.
Who knows?
Yeah.
Who knows? Well, it's been a busy time, hasn't it? Because certainly for Kielder Observatory, but I think here in the Northeast, there's been a few events going on over the last month, really, talking about space and bringing people together from different areas, different concerns around the space world, the space theme, I guess, and a few conventions and meetings that have been going on, and Kielder's certainly been part of one of those. Yeah,
and I think the Northeast is often not the first place you would think of when you think about the space sector in the UK. Where can you get into the space sector in the UK? And we meet kids in schools as well who say, I'm never going to work for NASA. I'm never going to be able to work for ESA, the European Space Agency, or anything like that, because I'm in the Northeast. And that is totally wrong, because in the Northeast we have many different space projects that are currently underway, including things like putting satellites into space, the manufacture of satellites, and there's a lot of money now being invested by companies such as Lockheed Martin, who are a massive spaceflight company, and alongside UK Space and somebody else as well, who's investing quite a lot of money in the Northeast infrastructure for space.
And Northumbria University are developing a whole sort of space department.
Yeah, they are
as well, aren't they? Which is right next to the Central Motorway. Not where you would think a space department would be, but it's not launch pads. It's all about research and sort of teaching the next generation of space scientists.
That's it. And just at Sedgefield, you've got Net Park, which it produces some of the most incredible pieces of technology, some stuff which is in space on massive telescopes, in other parts of the world on massive telescopes, even things like down to microscopic level as well, things that works on discovering and finding out more about the coronavirus. All those kinds of bits of kit. Optics are very similar on a small and a large scale. So you see there's midge.
I've got a midge in my ear.
Yeah, midge in the ear. But one thing that always surprises me when I go to Net Park, and it's not like I go weekly. I feel like that makes it feel like I go weekly. I don't. I don't frequent Net Park. But when I go to the Centre of Advanced Instrumentation, which is part of Durham University, what amazes me is when I walk in and I see headlights from cars, and I think, oh yeah, they're lenses, and they do produce the molds for some car headlights, as well as your telescopes, some of your biggest telescopes in the world. I mean, right now, one of our friends and volunteers, Dr. Jürgen Schmoll, he's been working on some pretty big telescopes in other parts of the world, some huge projects. But he's a wonderful guy, an incredible instrument scientist, and just based in Durham.
So it's all going on here in the Northeast, but there's lots going on as well elsewhere in the world of space. And the Artemis lunar mission is something that a lot of people are talking about. NASA preparing key pieces now for this. And this is obviously the next significant step in space exploration, I guess, isn't it? To get people back on the moon, get anything back on the moon, in fact.
Yeah, and I'm really excited for this because in my lifetime, I've never been alive when someone set foot on the moon. So I think it's going to be a real pivotal moment for us millennials to experience that, and everybody after that as well, of course. And I hope it has the same effect that the first thing did. And it's a question that we often get asked at the observatory is, oh, did they really land on the moon, or was it just a Hollywood set? And over the years, I've kind of perfected my answer to what I think is the most acceptable answer that I can come out with without it turning into an argument. And generally, it's just I don't care. And the reason why I give that answer is because that period in history is really what created the scientists which came beyond. They were inspired by watching these images on the TV, or by people leaving our planet and going to these far-flung worlds, even though the moon's not that far away. And so I don't care, but I think and I hope this is what going back to the moon will do, because even over the last 50 years, 50, 60, how long has it been? 60 years? 50 years? 50 years? Yeah, just over 50 years.
56.
Yeah. So even over that period of time, we've lost a lot of dark sky. And we're losing our connection with the universe by not being able to see it anymore. And I do worry partially about what that's going to do for future generations, whether they're still going to look up at the night sky and wonder and then go and seek careers in relevant subjects, or if they just all want to be on TikTok.
They definitely want to be on that.
Influencers. If they can be space influencers, that's fine.
A space TikToker.
Yeah, that's fine.
Yeah.
And maybe they can do it from the moon or from Mars in the future.
Well, on the subject of that, obviously people know about Elon Musk and all the various satellites he's put in there for Starlink. In fact, you've got a Starlink on the roof of Kielder Observatory here as well. Fully invested in the project. But Amazon have got their own project as well, the Kuiper constellation. And this is like they're doing a similar sort of thing, increasing amounts of satellites going up, these mega constellations. And again, that is going to potentially at least change how the night sky would look.
It is, and it's a really interesting debate. And actually, just last week I was at the National Astronomy meeting in Durham, and there was a conversation around satellites which came up. And I actually thought that one of the chaps that was there, I'm not going to mention any names, but he's quite a well-known chap. I actually thought he was going to throw a chair across the room and it was all going to throw down. It descended into what I thought was going to be this huge big argument, because the thing is with satellites is they are a problem for us when we're taking astro images of the night sky, but it's usually at very key times when the sun is hitting it or when the moon's hitting it. So it's only when it's being illuminated by something that the satellite is going to appear in the image. If we're in complete astronomical darkness, then chances are we won't get as many streaks, if any streaks at all. And the argument was that, well, astronomers should just calm down, that they can still do their observations during astronomical darkness. But that's not the case, because there is astronomy which is done at dusk for a start. And then also on top of that, if you're taking an image of something and you're looking at something very, 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 very small, and a satellite comes between you and that image, and you're using a telescope that's costing hundreds of dollars per second to use, and you have to recalibrate and do it again because you didn't realise that satellite was there, then it's a problem. And this is where the regulation of knowing where things are, knowing how much is up there, and restricting how much is up there come in. Because if we know they're there, we can make exceptions for it. But also, if too much ends up there, there's problems that can occur from that, such as the very scary Kessler effect, which is where if a satellite was to, I don't know, go off course or crash into another satellite and loads of debris ended up firing off in all directions, this debris is moving at like 18,000 miles an hour. It's like bullets. It's going to cut through other satellites.
The movie Gravity, isn't it?
Yeah, exactly.
All kicks off there, and
and then you end up with this cascading effect where things are crashing into each other, things are breaking apart, and you reach a point whereby there's so much debris kicking around in Earth's orbit that you can't put anything there anymore. And you can't escape Earth now, because if you do, you're going to get pelted by stuff that's doing 17,000 miles an hour.
Yeah.
And it's just going to cut through you like butter. So that is a quite scary prospect. But that being said, and we always look at the headlines in these things and think, ooh, scary headline, it's the worst case scenario, we catastrophize everything. But there is a great deal of investment happening and a great deal of caution happening in the background. There's places working on regulations, but also people who are putting these vast quantities of satellites in space, it's in their interest to make sure that measures are in place. Otherwise, they lose their entire network. So people like Elon Musk, Jeff Bezos, etc., 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 whoever else is putting big constellations in space, they are working on programs which are looking at how you can safely maintain orbits, how you can contain any kind of disasters or catastrophes to prevent the Kessler effect from happening, clean up space. There's a lot of space debris up there that doesn't need to be there anymore.
Yeah, that's the thing. There's so much stuff that goes up there, doesn't come back.
Yeah,
and they do obviously try every now and again, but there is way more sort of redundant gear orbiting the Earth than actually stuff that's probably being used, I would think.
For sure, and it's in their interest to clean that up. So there is work being done to try and clean up space.
It's a big job. Somebody's got to do it. But obviously, when these private companies, people maybe focus on the the downsides. But the amount of investment, though, that the likes of SpaceX, and obviously Amazon now involved as well, and other companies, it is really useful for the likes of NASA, as we've seen. They've been bailed out more than once by SpaceX, and SpaceX have got this Falcon 9 coming up for the 500th launch, and also a 29th reuse of the first stage booster as well. You might have seen this booster coming down. It's actually done 29 missions now, which is that's pretty impressive when you consider the years and years we went with the space shuttle era, where a lot of stuff just ended up either in orbit or floating back into the sea and might have got used again, but might not have done because it was full of ocean.
Yeah, and the funny thing is with this debate as well around the private companies being used by governments, there is a debate in that in itself, which again nearly set people off fighting last week. But it shows you that the technology is there. The technology is there to be used. And what I always try and encourage people to do is look past the figureheads of any organisation. I mean, many of the large organisations in the world, you can start to really scrutinise their figureheads, and you could instantly take a disliking to any one of them. It's just some are louder than others, or more noticeable than others. But once you look past that and you look at the people who are actually doing the grunt work, the people who are really starting to break technology and create things that humans, it's amazing that humans can do it. I mean, it boggles my mind when I see the complexity and the intricacy in some of these machines that we make. It's almost like it's been made by some advanced civilization, but no, that's us. That's humans that have done that. And focus on those, and also on the good stuff. Remember the good stuff that comes from it. By breaking technology, we can find out new things that can help save lives, that can help make human life more comfortable. And I know it's not all about human life. I know it's about also living in harmony with the rest of the universe. But how do you define that harmony? Is my question. If we were never meant to get to this point where we create technology, why have we?
Yeah. What's the benefit of it?
Yeah.
Yeah.
It's there for us to develop and use.
And well, that's how space travel came about. It was through curiosity and advancement, wasn't it? And you build on things and you look to move the world on. Let's talk about a few things in space that might have been in the news. The cosmic fossil. Talk to us about that. I mean, it sounds like really all action, but really dull at the same time, because fossil is not a very exciting word. But nonetheless, one's been found on the far edges of the early solar system. What could it mean? Because it is deep in our solar system at the moment.
Deep it is. It's called ammonite.
Okay, there it is, the cosmic fossil.
Yeah, the cosmic fossil. It's a reasonably large, 380 kilometre wide piece of stuff that's beyond Pluto's orbit.
That's a bigger fossil than you'd find on a beach.
It definitely
380 kilometres.
Yeah,
It's like the width of, well, it's more than the width of the UK.
45 times the width or the height of Mount Everest.
Right, that's quite a size. That's quite sizable. I would not call that a fossil. I would call that a meteorite.
Yeah.
Or asteroid or whatever. Actually, asteroid, isn't it? But yeah.
Yeah, asteroid or planetoid or small
massive rock,
small planet, dwarf planet. Yeah, it kind of sits in this category of dwarf planet, I guess. Does this? But then there's still a thought around whether or not there is another big enough planet out there, big planet, Planet 9, the infamous Planet 9. But the discovery of this kind of almost makes it less likely that there is a Planet 9. And it's because of the Subaru telescope located on Hawaii's Mauna Kea volcano. Those observations of this other planet could be what they initially thought were signs that there is Planet 9. Sometimes you don't need to make a direct observation of a planet to know that it's there, and this is how Uranus and Neptune really were found, was by looking at the effects of other things around them. Similar to how we found black holes, we saw the effects of other things around it, and in the same way, this is why we thought, oh, maybe there's a Planet 9 as well, because and Planet 9, I know we called Pluto Planet 9 once, but we don't now. Yeah. And that's it. It's Neil deGrasse Tyson's fault, not mine. Anyway, so yeah, this kind of destabilizes that theory around Planet 9, because it could be that there's just larger asteroids lingering around in that orbit out there that are actually creating that effect that we thought may be another ninth planet.
And there's also another story, wasn't there, that was a few weeks ago now, but about another asteroid that was it actually a comet coming through that's going to be passing very close to Earth, but actually quite far away.
Yeah, really far away, yeah, millions of miles away. Actually, it might be getting a little bit closer than that. No, I think it is millions of miles on its closest approach. Its closest approach is in October this year. But I'm getting a little bit hopeful that we may be able to just see it with a small telescope.
Okay.
And this is because this thing is only the third time that an interstellar asteroid has been spotted coming into our solar system. And you can spot these because they're doing a much quicker speed than stuff would do in our solar system, and at strange angles they enter in. And this one, the third one, is probably icy. In fact, I think last week in Durham, it was announced that it is an icy body, so like a comet, and as it gets closer to our sun, it'll start to, of course, outgas, as we call it, where the ice starts to no longer want to be ice.
Yeah, because it sort of just basically starts to melt in an industrial fashion. Yeah,
in industrial fashion. We call this sublimation, where solid ice goes into a gaseous or water vapor state, and it creates these beautiful big tails, and that's hopefully going to start to happen, and maybe that'll enable us to see it as well.
You just never know with comets, though, do you? Until they turn up.
You never know, and you know, it could still be aliens, because when the first one, the first one that we'd ever spotted that came into the solar system, the one that was poo-shaped. That one, it was
that its official name?
It was called a muamua, which means the visitor in Hawaiian.
Oh, not massive poo.
So not massive poo.
Yeah,
I mean, you could call it that if you want. So when that first came into the solar system, everybody was alight with the fact that it could be aliens, and then it was like, oh no, it's just this long cylindrical rock. And it came flying in and zipped out again, but it started to pick up a bit of speed when it was zipping out, and people were like, "Oh, maybe this is some kind of solar sail that it's got, and it's able to now escape as a result of that, and it's aliens." And so it keeps coming back at every now and again. Is it these interstellar visitors are indeed aliens? But the thing that I love to think about with this is that This is a little rock which has been formed way off in the distant parts of our galaxy. God knows how far away it's travelled. The estimate is that this thing could be about 7 billion years old. And that's because these things form at the very, very early stages of the solar system that they were formed within, just like our comets and asteroids were formed in very early stages of our solar system's creation 4.5 billion years ago. And so for this thing to have travelled through the rest of our galaxy to us here, 7 billion years old there or thereabouts this thing could be, and I just think that's amazing. Imagine what we'll learn from that when we get a little bit closer to it.
It's ridiculous to think that this thing has been hurtling through space for 7 billion years.
Yeah.
And
minding its own business.
Yeah, minding its own business.
Yeah.
And now it's, headline news and tabloids
yeah.
on Earth. And it's like it's built up for 7 billion years. But that is, a phenomenal thing that it's been going, since the dawn of time, really, as far as we're concerned.
Yeah, for sure. Since before our sun was even a sun. And there is likely that there's bits of our solar system that have been flung off somewhere else into the universe as well, into the galaxy. So it could well be that there's other, civilizations nearby who are kind of going, oh look, there's an interstellar visitor coming to us, and it's actually from our little solar system.
Piece of our solar system. Obviously, this time of year, stargazing, you've got to stay up pretty late, although we are back over the solstice now and heading back towards the longer nights, but we're a bit of a way off yet, but obviously stay up later. But nonetheless, there are things that you can see this time of year. The summer triangle being one of the main ones.
Well, it's a good one, that one. I like the summer triangle. It's a very obvious one at this time of year, but it's a good one. Three big stars, Vega, Altair and Deneb. I like Deneb because it means bum. Apparently. It's in the back end of Cygnus, the Swan. And Cygnus, the Swan, this is a constellation, Cygnus. It looks like it's flying through the Milky Way. If you trace it from tail feather to head, it's flying through the Milky Way. So when you see the summer triangle, the Milky Way is cutting through the summer triangle. But it's also a time, July in particular, is a time of celebration in Japan. And it's because there's a story that I've been sharing with everybody and boring people to tears with it, but I really like it, is that on the 7th day of the 7th lunar month, so the 7th of July, they celebrate Tanabata Festival, which is Star Festival. And the reason to do that is because it surrounds a story which actually comes from China, where two lovers, they got married and they were obsessed with each other, and then their productivity levels at work went down. So their parents went, nah, you're separated. We're going to put you in that house, you in that house. And there was a river that separated the two lovers. And and they were allowed to meet once a year on the 7th day of the 7th lunar month across a bridge. And so in the sky, when we see the Milky Way, there's Altair and Vega, and Altair and Vega are the separated lovers. And they meet in July. So there, I just think it's a nice story.
There are a lot of cultural stories about, to do with the night sky, a lot like that, though, aren't there? Certainly, in sort of parts of the world. I think particularly in the east, like Far East, also Australia as well. The native Australians. There's a lot of stories like that.
Yeah, there is. New Zealand, they recently, over the last few years, they announced a new bank holiday to celebrate the rising of the Pleiades.
Wow!
And the Pleiades is seen across the world in various different ways and has various different meanings when it rises. One of which is fertility, and that's because it's part of the constellation of Taurus, the bull, who was seen as very strong fertility, fertility-like creatures. So there's lots of stories across the world. Oh, and I love unpicking them from different cultures around the world and seeing the common threads through some of them as well. It's fascinating, but I'm not going to spoil it too much.
No. You've got to save, keep
I've
some
got
of
to
the
save
drama.
some for later.
Keep some of your material.
And some for a project which is coming soon, which you'll be able to read all about.
Watch this space, folks. Noctilucent clouds. Now, I've seen some of these. There was a couple of nights where they were really bright, actually.
Yeah.
And keep your eyes peeled. And you notice them because, well, I noticed them particularly because it was 2 o'clock in the morning. Now I'm thinking, it's pretty light for 2 o'clock in the morning. And there was a great display of noctilucent clouds one night, I think right at the end of June. But that's certainly something to look out for this time of year.
They're one of my favourite things. I argue sometimes that they can be more spectacular than the aurora, and it's because they're more obvious. When you look across towards the northern horizon, beyond 11 o'clock at night, just a few hours after sunset and a few hours before sunrise is usually when they're at their best. You can sometimes see these little tiny tendril clouds hanging in the north. And they're incredible, not just because of the way that they look, but because of what they are as well. These things are tiny little bits of meteor dust as a result of the 4 billion pieces of... 4 million. That was an overestimate. 4 million pieces of rock that hit us every day. And all of that dust, debris, all of that material is kind of stuck in the mesosphere, which is a region of our atmosphere just underneath the stratosphere. So it's pretty high up, about 70 miles above our heads right now. And all of that dust is just sat hanging up there. And at this time of year, because the sun doesn't disappear completely across the horizon there, it's enough to just illuminate that layer of cloud, which at this time of year, the mesosphere is very, very cold as the cold air is displaced and the hot air is further down towards the ground, and so you get little ice crystals developing around them, and we get to see that at this altitude, this latitude, and it's a very special thing to the northern parts of the UK that we get to see much more regularly than the southern parts of the UK.
Yeah, absolutely.
And you can go too far north as well. If you go too far north, then I guess you've got to look south to be able to see. No, actually, I don't think it works that way. But
well, eventually, when you get too far north, everything is south, I suppose.
Yeah, for sure. But you'd be underneath them. And I remember a few years ago, I think it was 2018, when they were actually above your head across the northeast. They were really dramatic, and it was allegedly because of the amount of rockets that we'd sent up into the atmosphere or something. I don't think that was the case whatsoever, because we've been sending up a whole heap more in recent years, and we haven't had dramatic noctilucent clouds as a result.
So look out for noctilucent clouds at the moment, and yeah, on a clear night, look north, and you might see the sky a little bit more illuminated than you'd expect for the time of night, and that probably is it. Planets, a few planets around. Mercury, I know, has been around. Venus is becoming into fashion a little bit more at the moment.
Yeah, it is. Venus is in the morning sky at the moment, so the morning star. Venus often gets called the morning star or the evening star because it's pretty much the brightest thing in the sky after the moon and sun. But we'll forget about that.
But you'll see the sun at night, though.
Yeah, no. So Venus is great to see. I love Venus through a telescope as well, because if you do get a telescope on it, it goes through phases just like the moon does, and that's because it's inferior to us. It's further in, closer towards the sun to us. So when it's coming close to us on its orbit, it starts to create this little crescent as sunlight's reflected back towards the sun and not us. So you end up with this little, and it's actually when it's at its brightest as well as when it's at this tiny little crescent phase. It's just like a tiny little bright light on the horizon, on the pre-dawn sky. And then Mercury, Mercury is still lingering around, and it doesn't stick around for too long. When that sun disappears below that horizon there, we may start to see Mercury for a very short period of time, just a matter of less than an hour, I would say, and then it's gone. But Mercury is a great thing to look at through a telescope as well, because you don't get to see it often.
No, and obviously then heading further into the summer, once you get sort of back end of August into September, I know that I was getting alerts about the aurora last night, but it was way too light. But nonetheless, we're heading into another aurora season at the back end of the summer.
We are, and even with blue in the sky, the kind of intensity of the aurora that we've had over the last couple of years, I dare say there is probably some points in the night that you would be able to see a little bit of aurora activity as we start to creep into August in particular. So, yeah, always worth just keeping an eye out for it, especially if there's a really, really strong display. Maybe southern parts of the country may have a better chance of being able to see something
Meteor showers as well. There's always a few of those around.
Yeah, there is. The Southern Aquarids is this time of year. It's not one for us, really, but if you're going on holiday, then it's worth keeping an eye out for that. It peaks around the 29th, 30th of July. Great if you're in Mount Teedy, maybe. You're starting to get closer towards the equator. Still, maybe not far enough south. You probably want to get into the southern hemisphere to really get the full effect of that. Few meteors might be visible in the UK though, but not so many. I wouldn't hang your hat on this one. I would wait until next month when the not the Pleiades. That's an asterism. When the Perseids is kicking around. Yeah, Perseids are kicking around, and those ones are always pretty good. But if I am right, the moon will be out, so that's not helpful. But still worth looking out for.
Okay, there's a few things to look out for. As far as Kielder Observatory then, lots going on this time of year, lots of extra sessions as well for families. We're into the school holidays just starting around now in most places. And lots of family events are lined up too.
Loads of family events. The last week in July, in fact, we are at Fenwick for an entire week delivering events there as well.
Wow, okay.
So you can come visit us at Fenwick. Book your tickets now on Fenwick's website. We were also doing an adult event on the Friday of that week as well, the very last week in July, and that's focusing around the aurora and taking photographs of it. So we'll be doing some light painting workshops, which are always great fun. I love doing those. So that's to look out for. We've got loads of events at the observatory as well. Kids events are certainly packing out for the school holidays. Our average occupancy for August is 100%.
Not a bad average.
In fact, last year it was 102% because we had to add events onto the calendar and we don't always do that. It was just because we had the capacity to be able to do that. But generally, it's what's there is what's there. If you don't book it, you don't get it, and that's it. So book tickets now. In August, there's also a one-off thing that we're doing at the Queen's Hall. Sorry, not at the Queen's Hall. At the Forum in Hexham, called Cosmic Frequencies. And I'm doing a very short talk there about the scale of the universe. So check out that as well, Cosmic Frequencies at the Forum in Hexham. And there's a group called the Funkanauts.
Are they astronauts turned funksters? I mean, there should be, really.
I'm really interested to hear their music. I purposefully have left it as a surprise. I don't want to hear their music until I see them. So that to look forward to as well.
Well, we might do a podcast from there as well. So we'll see about that, because there's obviously a lot of stuff going on there with regards the universe from various different people. I think that Pratt does us. There's all sorts of creepy crawly starting to appear now.
There is, yeah. Just another thing on that, actually. They're focused on the on that event is about aliens, I think. So it might end up getting quite an interesting Q&A may come out of that. And also we didn't mention that we have had a refurbishment. We closed in June for our refurbishment, and we've smarted the place, or snazzed the place. What's the word to use?
Jazzed the place up.
Jazzed the place up.
Snazzed the place up.
Snazzed the place
up. That works
up.
as well.
Yeah, that works as well.
Yeah.
So we've got a bigger gift shop. We've got telescopes you can now buy as well.
You can buy really nice looking smart telescopes.
And you can even win one at the moment as well, which details of that are on our social media pages.
And they're amazing things as well.
Yeah.
Like, if you're looking for ideas for,
Christmas.
I don't know, Christmas presents, birthday presents, anniversary presents, any presents, or just to treat yourself, then, definitely a smart telescope is worth looking at.
And they only start from about 400 quid.
Which, obviously that's not cheap, but nonetheless, it's for when you see the results you get with them.
And from a sky that isn't dark as well. The whole point in these telescopes is to make the universe accessible from your back garden, even if you have a light polluted sky. That being said, if you live in central London, I don't know how well it'd work. But it'd be interesting to see what the results are like.
You could try one, couldn't you? You could try it.
sure.
You could try it.
Yeah.
Well, to find out everything about the upcoming sessions, as Dan said, you need to book as soon as possible, certainly for those events through the school holidays, the family events, kids events and what have you particularly. But check out everything that is available, not just for the next month or so, but even further into time, the next pretty much year, I think, almost.
Yeah, pretty much all the way up to February.
Yeah, February, March or something like that, isn't it?
Yeah.
All available on the website right now, kielderobservatory.org. And, I'll let you get, when it gets dark, you'll be stargazing, I guess, but yeah, not quite there yet.
Clouds starting to loom in now, isn't it? Look at that.
A little bit. But anyway, you've got a few hours yet.